Okay guys, so in this video I am going to go through an entire paper and I'm going to show exactly how I'm answering every question, which hopefully will be really helpful to you as part of your revision. It's really important that you don't just watch this video. When you're watching me do chemistry, it can look really easy. The important thing isn't whether I can do it, it's whether you can do it. So you need to try this paper yourself first and then watch this video so that you can see what questions you're thinking about in the right way and which questions you might need to go and review. Okay, so how have I found this paper? I have gone to physics and maths tutor. Okay, be really careful that you're picking the right one. This top section is not the right section because it is for the non-IGCSE papers. You need to scroll all the way down to IGCSEs, the international ones, and we are EdXL. So you've got paper 1 and paper 2. Today I'm going to focus on a paper 1. And if we go into here, the most recent paper 1 that there is are the January 2022 papers. You'll see that for every session there are 2 papers available. Those are just different time zones. You can do either of those papers. So January 22R and January 22 are both paper 1. They're both papers you can do. It's just that because this is an international GCSE, you've got 2 different papers so that they can be done in 2 different time blocks. Because obviously, if you're doing an IGCSE paper in Australia, you're going to be asleep when we're doing the exam and vice versa. So that's why there's got to be 2. So I've selected this one, just the January 2022 without the R. And this is the paper. You'll see that it says double award on the front. Don't worry about that. Remember, the paper 1 is common between the double award and the separate science. You've then got the extra paper 2, which covers the separate science only material. Make sure you've got all the equipment that you need. You need a calculator, you need a ruler, you need your periodic table. In the exam you'll be provided with one, but for today make sure you've got your periodic table available. Okay, total mark for the paper is 110 marks and you have got 120 minutes, 2 hours to answer the paper. So if you haven't already answered it, you need to pause the video now. Please put aside a proper 2-hour block. Put your phone away. Make sure that the only thing that's showing on your laptop screen is a periodic table. And you need to spend 2 hours answering everything you can on this paper. Okay, so question number 1 is about mixtures and compounds, and the box gives some methods used to separate mixtures. We've got to choose methods from the box to answer the following questions. So each method may be used once, more than once, or not at all. Identify a method to separate a single food dye from a mixture of food dyes. The key part of this question that tells you the answer is the fact that it is talking about a dye, because the dyes only involve a single method that can be used to separate coloured substances, which are dyes, which is chromatography. Identify a method to separate gasoline from crude oil. Again, there should be one answer that's jumping out at you here because only one of them works for crude oil. But you can also get it from the idea that gasoline is a liquid, crude oil is also a liquid, so we're looking for a method that can be used to separate 2 liquids from each other, which is fractional distillation. And then final question, identify a method to separate water from copper sulfate solution. It's telling you in the question that it wants water as a product. So the trick here is to recognise that the answer is not looking for crystallisation, because crystallisation would be to separate the copper sulfate from the solution. To separate the water out, you need to use simple distillation as a technique. Okay, the diagram represents a molecule. Explain why this molecule is a compound. So here you need to be aware of the definition for a compound, and you need to link that to what you are seeing. So a compound is something that contains two different kinds of atoms or two different elements would also be acceptable. And the key that shows you it's a compound rather than a mixture is that they are bonded together. Okay, I'm writing my answers as bullet points. You can do that in an exam if you wish to, or if you prefer to carry on writing in full sentences, as you probably do in some other subjects, you are free to do that as well. The molecular formula of a compound is C3H5N3O9. Number of different elements, we are looking at the letters. There are 4 different letters, so there are 4 different kinds of elements present. And then the number of atoms, we just have to add together the number of atoms which are present, which is going to give us 20 atoms. You get the mark for saying 20. You don't necessarily have to show you're working for this one. Next question is about rusting. A simplified formula for rust is Fe2O3. Name the 2 substances needed for iron to rust. Okay, so this is a knowledge-based question. You should be recalling this. Oxygen as a gas is needed, and water is needed for things to rust. The chemical name for rust we can get from the formula. Okay, so we've got the formula up at the top, is going to be iron oxide. Now, it would be good to give a bit more detail in our answer here, because as we know, iron can be Fe2+, or it can be Fe3+ as an ion. So here we're going to work out which one it is. We've got 3 oxygens, each of which has got a -2 charge. So altogether my oxygens are going to have a charge of -6. Therefore, to balance that, I need 2 ions to add up to +6, which tells us that each ion has a charge of +3. So in brackets here, I'm just going to put my Roman numeral for 3 to show that I understand that the ion is 3+. Okay, the type of reaction that occurs in the rusting of iron. Okay, well, we've already said that what we're doing is we are taking iron and we are turning it into iron oxide. So that tells you what type of reaction it is. You can see the iron is gaining oxygen, which is another word for that is oxidation. Some iron objects are coated with a layer of zinc to prevent rusting. Name this type of rust prevention. Okay, again, this is a knowledge-based question. The process is called galvanizing. That's where you spray the iron object with a layer of zinc. Explain how this type of rust prevention continues to protect the iron when the layer of zinc is damaged. Okay, so this is basically explaining your reactivity series. Zinc is above iron in the reactivity series. So it will react before the iron does. So that is what we are explaining. Okay, it's 2 marks, this question. So we need to make 2 distinct points. Okay, so I'm going to get 1 mark for explaining that the zinc is more reactive than the iron. And the second mark will be for explaining what that means. So therefore, it will react before the iron, or in preference to the iron. That should be enough to get me 2 marks there. And give 2 other methods used to prevent iron from rusting. So anything that prevents iron from rusting here. So I'm going to say paint the object. And also you could coat the object with oil or grease. You could also coat the object with a plastic coating that would prevent it from rusting as well. So any of those answers should be acceptable. Okay, we're now on changes of state. Okay, so the box gives words relating to changes of state. Select the correct word from the box for each change of state. Okay, so this should be relatively straightforward. Solid to liquid is going to be melting. Just think of ice. Okay, liquid to solid is going to be the opposite process. So freezing. And then we've got solid straight to gas without doing anything in between. So the thing that a lot of people are going to miss or get wrong here is they're going to go for evaporation, because that's how you make a gas. Remember, that's going from a gas to from a liquid to a gas. We're going from a solid to a gas here. So sublimation is the key word for that. Okay, ammonia gas and hydrogen chloride gas are mixing, and they are forming a white solid of ammonium chloride here in our diagram. Okay, so we've got 2 pieces of cotton wool at each end of the tube. One is soaked in concentrated ammonia and one soaked in concentrated hydrochloric acid. They're put into opposite ends of the tube at the same time. And after several minutes, the ring of ammonium chloride forms. State the name given to the spreading out of gas particles. That is diffusion, the gradual spreading of gas particles. How does the diagram show that the particles of ammonia gas are travelling at higher speeds than the particles of hydrogen chloride gas? Okay, well, we can see there that the ring is further towards the right-hand side. So if we look at the distances, the ammonia has travelled a further distance than the hydrogen chloride gas in the same amount of time. So that means it is travelling more quickly. So that's how we would know this. So the ammonia travels further in the same amount of time. Okay, gas particles travel at high speeds. So why does the white ring of ammonium chlorides take several minutes to form? Now this goes back to the concept which you will have studied in Year 7 called Brownian motion, which is the idea that although the tube looks empty, it is obviously not empty, it's filled with air. So the ammonia and the hydrogen chloride have to get through all of those air particles. And as they are travelling down the tube, they are going to bump into all of those air particles. And that is going to slow them down. Okay, so the reason it takes several minutes to form are the tube is filled with air particles, which will collide with the reactants and slow them down. Might be slightly too much explanation because it's only 1 mark, but I'd rather write too much than too little. And then concentrated ammonia solution and hydrochloric acid are corrosive. One safety precaution. Well, I'm just going to go straight for our favourite one. They should be wearing goggles to protect the eyes. You could also possibly mention gloves, something like that, but goggles is probably the quickest option. Okay, so far I've answered 23 marks worth of questions. So I've done that in about 12 minutes, so we're doing quite well for time. Okay, so here we've got apparatus to find the percentage of oxygen in a gaseous mixture of oxygen and argon. Now immediately that tells us something really, really important, because usually we would expect the percentage of oxygen in air to come out at about 20%. This is not a mixture of air though, it's a mixture of oxygen and argon. So we're not going to be worried if our answer to this experiment comes out as very different from 20%, because that is not the situation that we are being asked about here. We're being asked about a completely different mixture. Okay, so we're going to have a read through our method. And then we are asked to give a reason why the copper powder is heated. Well, copper has got a fairly low reactivity, and so heating it up will increase the rate of reaction, as copper is not very reactive. So if we just left this to react at room temperature, it would not react very quickly, if at all. Okay, state why argon is unreactive. Well, we know that argon is an example of a noble gas, and we know that noble gases are unreactive because they have got full outer shells. So it has a full outer shell. And give the name of the black powder formed when oxygen reacts with copper. Well, copper plus oxygen gives copper oxide. And if you have learnt your colours, you know that copper oxide is a dark black powder. Okay, the table shows the teacher's results. So we can see that the reading on syringe A is gradually going down as the oxygen is being used up. So state how the results show that all the oxygen has reacted. Well, we can see if we look at our last 3 readings that all of the last 3 readings are the same. So the volume of gas remains constant for the last 3 readings. Okay, the volume of gas in the glass tube and the connecting tubes is 175 centimetres cubed. So let's just go back to our diagram. Okay, so the volume of gas which is in the syringes, hold on, let me reread that. Apologies, in the glass tube and the connecting tubes. So not in the syringes. In the glass tubes and the connecting tubes is 175. Okay, so contained in all of that, we've got 175 centimetres cubed. We have also got then the gas that is in that syringe. Syringe B is empty. We can see that because the plunger is pushed all the way in. So we've also got the gas that is in syringe A, and our experimental data tells us how much that was. 78 centimetres cubed. Okay, so I know that my total volume of my gas at the beginning is 178 plus 78, which is 253. Okay, I also know that the amount of oxygen present, if I look at my data, okay, I've gone from 78 to 58, so that means that 20 centimetres of my air was oxygen, because remember the oxygen has reacted with the copper and has been lost, so that loss shows me the amount of oxygen. So I am going to do 20 divided by 253, and it wants the answer as a percentage, so multiplied by 100, and that should give me 7.9% oxygen. So if you remember what I said at the start of the question, you can see here now why reading the question is so important, because if you got this answer and you were expecting it to be in air, you'd be going, oh, I think I've done something wrong here. Suggest one reason why the calculated percentage of oxygen in the mixture might not be accurate. Okay, so if we go back up to the top, okay, read their method. Have they done anything wrong? Not really. They've repeated it. They've waited until the mass becomes constant. So that's not a problem. So therefore I would say the most common thing that could be wrong with it is that the connecting tubes are not connected properly and there is a leak somewhere. So there could be a leak in the connecting tubes. Okay. Number 5 is a nice little atomic structure question. So it's asking you for the relative masses and charges of protons, neutrons and electrons. So this you just need to know. Okay, your protons and neutrons have a mass of 1 each, and then protons are positive, neutrons are neutral. So that completes that question. Okay, the meaning of the term isotopes. Okay, so here you've got to be careful with how you start it. Okay, they are atoms of an element, and the word atoms is really important here. So atoms of an element with the same number of protons or the same atomic number and a different number of neutrons or a different mass number. If you're talking about number of protons, talk about number of neutrons. If you're talking about atomic number, talk about mass number. And then give the number of protons, neutrons and electrons in one atom of this isotope. So make sure that you're using the isotope that they have given you. Okay, so magnesium, you've got two numbers, 26 and 12. The smaller number tells you the number of protons. So that's going to be 12. The number of neutrons is the difference between the mass number and the atomic number. So that's going to be 14. And your number of electrons in an atom, which it is always the same as your number of protons. So will also be 12. Okay, we need to work out the relative atomic mass. Now it has already told you what the relative atomic mass is, so you don't get a mark just for giving the answer here, because it has given you the answer already. Your marks are for showing you're working. So you take your percentage of isotope 1 and multiply them together. And you add that to your percentage of isotope 2 and your percentage of isotope 3. And once you have that number, you then divide by 100. It doesn't matter if you decide to do that in one step and you first work out your top line and then separately divide it by 100, or if you choose to do it all in one go, as long as you make sure you get your BODMAS right. And if you do, you get an answer of 24.32. So your answer there is for your working. Okay, 1 mole of magnesium has a mass of 24.32 grams, and there are 6.022 times 10 to the power of 23 atoms in 1 mole. Calculate the mass of 1 atom. Okay, so we know that 0.662 times 10 to the 23 atoms have a mass of 24.32 grams. So to work out the mass of 1 atom, we take our 24.32 and we divide that by the number of atoms that we've got. And that will give you an answer that is very small. Okay, it says give your answer to 4 significant figures. Now, the answer that you get is in standard form. The standard form part, the times 10 to the power of minus 23, is not included in your significant figures. So we want it to be 4 digits before we get to the times 10 to the power of minus 23, which gives me an answer of 4.039 times 10 to the power of minus 23. Okay. Equation for the reaction between magnesium and oxygen is as follows. Determine the maximum amount in moles of magnesium oxide that can be produced. Okay, so in this question we've got a number of moles of magnesium and a number of moles of oxygen. So the first thing that you have to do is you have to work out which of your 2 reagents is your limiting reagent or your limiting reactant, because that is going to control how much product you make. Okay, there are multiple ways you can do this. I'm going to go through the most step-by-step method. Okay, so we're starting with that many moles. I'm going to imagine that I have reacted 0.1 moles of this oxygen. If I react 0.1 moles of that oxygen, I will be left with 0.1. The magnesium that reacts with that oxygen, in front of the magnesium is a 2. Which tells me that I am going to have 2 moles of magnesium reacting for every 1 mole of oxygen. So if I react 0.1 moles of oxygen, I will react 0.2 moles of magnesium. I've still got some of both left, so I'm going to do the same thing again. I've reacted 0.1 moles of oxygen, leaving me none left. And I've reacted 0.2 moles of magnesium to go with that, and I still have some magnesium left. That tells me that the oxygen is my limiting reagent. So it is my oxygen that is going to control how much magnesium oxide I make. Now, oxygen and magnesium oxide are in a 1:2 ratio. I started off with 0.2 moles of oxygen, so I will have made 0.4 moles of magnesium oxide. If you've got a quicker way of doing it, that is absolutely fine. but that is the most step-by-step method I can think of. Okay, next question is about sodium oxide, and we've got the electronic configuration of atoms of sodium and atoms of oxygen, and it's asking us to describe what the changes in the electron structures are going to look like. Okay, so sodium's got 1 on its outer shell, oxygen has got 6. So we know that sodium is going to lose 1 and oxygen is going to gain 2. So that is where I am going to start. Okay, so sodium loses 1 electron. Okay, it tells me here that it wants me to talk about the ions. So I'm going to say to become the Na plus ion, and oxygen gains 2 electrons to become the O2 minus ion. Okay. It doesn't ask us to talk about the formula, but I think it's a good idea to do so just in case. So there are 2 sodium ions for every 1 oxygen. Because sodium's losing 1, oxygen's gaining 2, and therefore you need them to have 2 sodiums. It gives you the formula up here, so there won't be a mark here for giving the formula. If it hasn't given you the formula, then you would write it as part of your answer, but they already told us that in the question, so here that definitely won't be a mark. Calculate the relative formula mass of sodium oxide. Okay, so relative formula mass, we need to find out the masses of each one. Sodium is 23, and there are 2 of them. Oxygen is 16, which gives us a total MR of 62. 1 mark. Okay, explain why solid sodium oxide does not conduct electricity. Okay, so we've got solid sodium oxide. So the first thing we need to do is we need to determine what kind of bonding is present. Now, in the earlier part of the question, we were always talking there about ions. So we know that it is going to be ionic bonding. And you should know that when we are talking about ionic bonding, we are talking about giant ionic lattices. Okay, so the ions are present in a giant ionic lattice. And one of the things about giant ionic lattices is they do not conduct when they are solid, and the reasons for that is when solid, the ions are not free to move and carry charge. Which means they can't conduct electricity. Okay, give a test to show that sodium oxide contains sodium ions. So this is about you knowing your tests. The test for sodium is the flame test, and you will get a yellow flame if there is sodium present. When sodium oxide is heated, it reacts to form sodium metal and sodium peroxide. Now, this is an equation you haven't seen before, but it gives you all of the information that you need. You know that your products are going to be Na and Na2O2 because they've given you that in the question. And now you just need to balance it. So usually I would say balance your oxygens last. So let's have a look at it. We've got 2 sodiums on the left, 3 sodiums on the right. Now, that isn't necessarily an obvious and easy thing to balance because 2 and 3 are not factors of each other. So just for a second, I am going to consider the oxygen first this time. I've got 1 oxygen on the left, 2 oxygens on the right. So I'm going to put a 2 in front of my Na2O to balance my oxygens. I've now got 4 sodiums on the left and 3 on the right, which is much easier to balance because I can just put a 2 in front of the sodium there. So it's not necessarily a hard rule that you have to balance oxygen last. It's normally helpful if you're doing combustion equations, but if you can see that the other substance doesn't work, balance your oxygen. Okay, question number 7, we're looking at soluble and insoluble compounds. So this is going to require you to know your solubility rules. They've mixed some different solutions together and they want to know in which of the tubes will a precipitate form. Okay, so the products of my first tube are going to be copper chloride and calcium sulfate. Tube number 2, I'm going to have potassium nitrate and magnesium sulfate. And tube number 3, I'm going to have sodium sulfate and I'm going to have copper carbonate. Alright, so looking at tube number 1, copper chloride. Well, most chlorides are soluble except barium chloride and silver chloride. So copper chloride is soluble. Most sulfates are soluble except barium and calcium. So this one will not be soluble, so it will form a precipitate. The precipitate will be calcium sulfate. Okay, all potassium and nitrate salts are soluble, so potassium nitrate is definitely soluble. Magnesium sulfate, all sulfates are soluble except calcium and barium, so there is no precipitate there. Okay, all sodium salts are soluble, so sodium sulfate is soluble. Most carbonates are insoluble except the group 1 and ammonium ones, so there will be a precipitate in that case. So C, 1 and 3. Okay, a student mixes the solutions which contain equal numbers of moles. So here I already know that these are going to react exactly. There will be no leftover AgNO3 and no leftover NaCl. State the colour of the precipitate of silver chloride. This is the product of testing for chlorides. Silver chloride is white, silver bromide is cream, silver iodide is yellow. Okay, and the student wants to obtain pure dry crystals of sodium nitrate, which decomposes at a temperature above 300 degrees Celsius. Tell me how they're going to do that. Okay, so because the question says that they have mixed together solutions containing equal moles, we are assuming that that has already been done. So what we have got is a beaker that contains aqueous NaNO3, so NaNO3 dissolved in water, and a solid component of AgCl. That's what we have. And it wants us to get the NaNO3 out of that solution as crystals. Okay, so the first thing that we are going to want to do is get rid of that solid AgCl which is settled at the bottom of my beaker. So that is going to be the first thing that I will do. I'm going to filter out my AgCl using filter paper and a funnel. Remember, I said you don't have to write in complete sentences. If you want to bullet point this, that's absolutely fine. Okay, we're looking for 5 points, so I would imagine that I'm going to need 5 bullets. So that's bullet point number 1. Okay, I'm then going to heat my solution of NaNO3 aqueous in a crystallizing dish. I'm going to do that until it reaches the crystallization point, or until the first crystals start to form. Okay, so I've already got 3 points there. Okay, once it reaches the crystallization point, I'm going to leave it to cool and the crystals will start to form. I am going to filter out the excess water, and I am then going to dry my crystals. Now, because it's told me in the question that the crystals decompose above 300, this case I'm not going to use an oven. I'm just going to put in a warm place, e.g. a windowsill, because if I heated it in an oven, my crystals might decompose. Okay, so I have got 6 points there. That should be enough to get me 6 marks. We'll look at it when I go through the mark scheme. Okay, and give an advantage of mixing the solutions containing equal amounts in moles. Well, there will be no excess reagents. So these don't have to be removed, which would happen if we had an excess. Alright, question number 8. We've got 6 organic compounds. Give the letter of a compound which is not shown as a displayed formula. Okay, so at first glance they all look like they're displayed as displayed formulas because they're all showing the bonds and the pictures. However, if you look really closely, that CH3 group in A, it doesn't show all of the bonds that are present. So that is the one. If this was displayed, you'd expect to see the hydrogens coming out like that, which they aren't. Okay, give the letter of a saturated compound with the general formula CnH2n. Okay, now they're trying to trick you here. They're trying to make you go for E, because E is obviously an alkene, and you know that alkenes have got that formula. However, the question says a saturated compound. Saturated compounds only have single bonds. There are no double bonds. So you're looking for something that still has that formula, but only has single bonds. And the only one that does that is C. Okay, asking you then to name compound E. Compound E is an alkene, so it's going to end in -ene. And it has got 3 carbons, so it is going to be propene. Okay, compound A and compound D are isomers. Why are they isomers? Okay, well, this is going to be the same explanation. Whichever compounds it's talking about, they have the same molecular formula. That's the number of carbons and hydrogens in the molecule, but different structural formula. That's how they are bonded together. You can describe that in words and, talk about the fact they contain the same number of carbon and hydrogen atoms, but they have got different structures. They're connected by different bonds, but this is the quickest and most succinct way of explaining it. Okay, compound F reacts with bromine in the presence of ultraviolet light. Complete the equation for this reaction. I'm just going to draw it up here for now. Help if that hydrogen would stay in place. That's a hydrogen up there. Okay, and I'm adding bromine. Now, the fact that this is a saturated compound, there are no double bonds, means that I can't just add my bromine on. If I tried to add my bromine to my carbon, I'd end up with more than 4 bonds, so that is not possible. Instead, I am going to swap one of my hydrogens with a bromine. And then the other bromine is going to pair up with the hydrogen that was lost. So that is going to be my product. So CH3Br plus HBr. And the name of this type of reaction, well, it's just like football. When you swap a player for another player, you are making a substitution. This is a substitution reaction. Okay, empirical formula, and they have given you what the answer is, so you're not going to get a mark here for the answer. It is all about your working. Remember to lay it out neatly. Mass. In fact, I'm going to add an extra one. Mass. MR. Moles. Ratio. And I've got 3 elements. I've got carbon, hydrogen and chlorine. Alright, so in the question, all of my data is given as percentages, but that doesn't matter. We are just going to assume that we had 100 grams of it. If we had 100 grams of the compound there and 37.8% of it was carbon, then we have 37.8 grams, 6.3 grams and 55.9 grams. So it's exactly the same number. We are just now assuming that it's a mass. You need the MR of the element, which you're finding on the periodic table. Carbon has a mass of 12, hydrogen of 1 and chlorine is 35.5. And you're going to work out the number of moles by dividing the mass by the MR, which is why I added the MR in there. It makes it nice and easy to do. Okay, and then number of moles, 37.8 divided by 12 is 3.15. 6.3 divided by 1 is obviously 6.3. And 55.9 divided by 35.5 is 1.57. Okay. Then we are going to work out our ratio. To do that, we decide which one is smallest and we divide by the smallest number. 1.57 is the smallest, so I'm going to divide everything by 1.57. Okay, 1.57 divided by itself is 1. 3.15 divided by 1.57 is 2, and 6.3 divided by 1.57 is 4. So we have then proven the ratio that is listed here. We've got 2 carbons, 4 hydrogens and 1 chlorine. It's good to get into the habit of writing that out. In this case, you won't get a mark for it because it was given to you in the question. But in some, it won't give you the formula. It will just give you the data. And then you must write this out as your final answer. So do it every time, and that way you won't forget to do it when it counts. Okay, relative formula mass of G is 127. Therefore, discover its molecular formula. So remember, this thing that we've just calculated here is the simplest ratio of carbons, hydrogens and chlorines in the atom. We don't know what the actual ratio is. So it could be C2H4Cl. It could be C4H8Cl2. It could be C6H12 and Cl6. It could be anything. Sorry, that would be Cl3. Could be anything. Okay. However, we need to know what it actually is. So we're going to take our C2H4Cl and we're going to work out the mass of that. So we're going to add together our 2 carbons, 24, our hydrogens and our 2 chlorines, and that's going to get you a mass of 63.5. Okay, if we look at that, 127 divided by 63.5 is equal to 2. So you have got 2 lots of C2H4Cl in each of the things in G. So you're going to double everything. So it's C4H8Cl2. Now you could have done that as well by just going through and working it out from over here. You could have worked out, okay, that's 63.5, the mass of that is 127, and you could have kept going until we saw what the actual answer was. But you don't need to do that. You can just do the division and that will tell you how many repeats you have got there. Okay, compound E is used to make an addition polymer. Complete the equation to show the part of the polymer formed by the 2 molecules. Okay, so it tells you you're adding 2 of them together and it gives you the formula. I am going to redraw this to make it a little bit easier to see. So that carbon has got 2 hydrogens on it. There's a double bond. The next carbon has got a hydrogen on it and it's also got a CH3 on it. So all I have done is I have taken this group here and I have combined it so that it looks like that, and that's going to make it way easier to draw. So I'm now imagining adding 2 of these together. So these 2 carbons are going to come from the first one and these 2 carbons are going to come from the second one. So imagining it, I've got 2 hydrogens, I've got a hydrogen and a CH3. That's what would normally go in our brackets with the N outside, but we're not adding N of them together, we're adding 2. So I've just got to show my second one as well. Okay, and then one problem caused by the disposal of addition polymers. You can have 2. There are 2 different disposal methods. There is landfill and there's burning them. Okay, the problem with landfill is that landfills are becoming full as polymers don't biodegrade. The problem with burning is that they produce toxic gases. 9. A student uses the separators to investigate the rate of reaction between calcium carbonate chips and dilute hydrochloric acid. They're reading the balance every 20 seconds. Explain why using a cotton wool plug increases the accuracy of the student's results. The cotton wool plug is there to stop any acid from splashing out of the conical flask, because as it reacts there's quite a lot of fizzing. It's possible that some of it might, tiny little drops, be splashed out of the balance, which is not going to give us accurate results. Okay, we've then got a chemical equation. Okay, helpfully in the question they have shown us the calcium carbonate chips. So the calcium carbonate chips are going to be solid. Acids are always aqueous because they are acidic substances dissolved in water. Water as a product will be a liquid because it can't be aqueous. You can't have water dissolved in water, that's just water. And carbon dioxide is obviously going to be a gas, hence the bubbles being released. Okay, the student uses the balance to find the decrease in mass of the flask and the contents, and we've got a graph of their results. Give a reason why there are some calcium carbonate chips remaining in the flask when the reaction stopped. Okay, because all of the hydrochloric acid had already reacted. Or you could phrase that the calcium carbonate is in excess. Okay, how would the student know that the reaction has stopped? Well, we can see when that happens on our graph. It happens at 100 seconds. How do we know it happened at 100 seconds? Because the mass remains constant. Just saying that it stops bubbling isn't really enough because sometimes the bubbles are so small that you don't really see them. The mass remaining constant is the best answer there. Okay, use your graph to determine the amount in moles of carbon dioxide produced. Okay, so I've got the MR, so I'm going to want the mass. Okay, so I'm going to need to work out how much carbon dioxide was lost. The decrease in mass is all happening because of the carbon dioxide. So I can see that I have lost 0.98 grams. That tells me that I've got 0.98 grams of carbon dioxide. Okay, so first mark will be for identifying the mass. Second mark will be for calculating the number of moles. N equals M over MR, which gives me 0.022 moles. Use the graph to calculate the rate of reaction at a time of 60 seconds. So in order to work out the rate at a specific time, you must draw a tangent to the curve at that point. Now this isn't going to be easy for me to do with a straight line because when I touch the screen it automatically moves it, but I'm going to do my best to do this with a ruler. Obviously yours will be better than mine. Okay, I've not got it quite on the line, so I'm going to redraw. Okay, so you're trying to line up a tangent line with the point that is at 60 seconds. That's not great, but it's also not terrible, so I'm going to try and do it using this. Okay, so to work out the gradient of a line, you do the change in the y-axis over the change in the x-axis. So the change in the y-axis is going to be equal to 1.10 minus 0.64, and the change in the x-axis is going to be, actually I've got the line wrong there, so it should be to there, is going to be 100 and so 20 divided by 5 is 4, so it'll be 104 seconds. Okay. So using a calculator, 1.01 minus 0.64 is 0.46, so I'm going to have 0.46 over 104. Okay, make sure that when you are working, you show your tangent clearly on your graph. You get a mark for showing the tangent, and you get a mark for showing all of your work. 0.4. Okay, and that gives us an answer 4.42 times 10 to the minus 3. The student repeats the investigation by diluting the original hydrochloric acid. They then determine the initial rate at different percentage concentrations. Describe the relationship between the initial rate and the percentage concentration. Okay, so we can see as the percentage concentration increases, so does the rate. However, it's worth 2 marks. That's unlikely to be enough for 2. Now the question only says describe, it doesn't say explain, so it's just about describing that relationship. So there must be something more to this. If you look at the graph, you can see that when the percentage concentration doubles, so does the rate. Okay, so we've doubled it from 20 to 40. And it's also doubled from 0.05 to 0.1. Let's check that. We're now doubling it from 40 to 80. Does it do the same thing? Yes, it does. It's doubled there as well. Okay, so we can say the relationship is directly proportional mathematically. Explain why changing the concentration of hydrochloric acid has an effect on the initial rate of the reaction. Well, we know that increasing concentration means that there are more particles of acid. So more collisions per second, or an increased frequency of collisions. And therefore a faster rate. I've written 3 points. It's only 2 marks, but I'm guaranteeing I should be able to get those marks. Okay, question number 10. This question is about substances which contain covalent bonds. Okay, and we are talking about nitrogen. Now, you might just have learnt to remember it, but I'm going to show you how to work it out. So first thing, we go to our periodic table. Nitrogen has got 7 electrons total, which means that it's going to have 2 on its first shell and 5 on its outer shell. The question has said only show the outer shell electrons, so I'm ignoring the 2 which are on the middle shell, and I'm just going to do my 5. Okay, so I've got 5 on that atom and 5 on this atom. Now, I know that I've got at least 1 bond, because otherwise it wouldn't be N2. So I'm going to put 1 of those from each one in the middle. So I've moved that one into the middle and that one into the middle. I then count the number of electrons that each nitrogen has got a share of. So 1, 2, 3, 4, 5, 6. 6 doesn't work. You have to have 8. So when you get in a situation like this, you put another pair in the middle. So I've taken away another electron from each one, and I've put a pair in the middle, and I'm going to count again. 1, 2, 3, 4, 5, 6, 7. Better, but still not there. So I'm going to have to do something else. I'm going to put another one in. Ooh, should have been an eraser. So that one and that one. I'm putting those in the middle as well. And now I count 1, 2, 3, 4, 5, 6, 7, 8. So other one, double check. 1, 2, 3, 4, 5, 6, 7, 8. Fine, we're ready. Done. Describe the forces of attraction in a covalent bond. Okay, so when you've got your covalent bond, you've got your shared area in the middle. You have your positive nuclei, and you've got your shared pair of electrons. And what is holding the substance together is the attractions between those negative electrons and the shared electron pair. What do we call the forces of attraction between two charged things, like a positive nucleus and a negative electron? We call them electrostatic attractions. So we're looking at the electrostatic attraction between the shared pair of electrons and the nuclei, because there are two of them, of the atoms. That's what a covalent bond is. Those are the attractions present. The attraction between the negative shared pair of electrons and the positive nuclei. We've got 3 different structures of carbon. Structure A has got 4 bonds, which tells you that it's diamond. And then we're being asked to compare graphite and C60 fullerene. Okay, so the key things here. Graphite is giant covalent, whereas C60, it tells you how many atoms are present, 60. That isn't considered giant, so this is a simple molecular or a molecular substance. So that's going to form the basis of my explanation. 4 marks. So 2 of those marks are going to be for stating the type of bonding, and then we're going to be asked to explain it. Okay, so in my answer I'm going to say that C60 is simple or molecular covalent. Therefore, what is being broken when it is heated are the weak intermolecular forces. And that does not take much heat energy. It's a comparative paragraph, we're comparing, so I'm saying it does not need as much energy. Okay, graphite is giant covalent. And contains many strong covalent bonds. These require more energy to break. That should be enough to get me my 4 marks. A chemical test to show that the substance is pure water. Okay, this is a test that you need to know. You add anhydrous copper sulfate, which is white in colour. And if the substance is water, it will go from white to blue. Okay, I should probably say if it's water, it will go from white to blue. Okay, what is a physical test? Physical test is its boiling point. So heat the liquid to its boiling point. If the boiling point is 100, then it's water. It's exactly 100. Okay. And then we've got a nice mathsy question. Alright, so we've got the mass of the boiling tube and the zinc sulfate. Calculate the maximum amount of water that can be produced. Okay, so first thing I'm going to do is work out how much of my hydrated zinc sulfate I've got. So I'm going to work that out using these two numbers. Subtract 41.64 from 54.46, and that gets me 12.82 grams. I've also got the MR of that substance, so I'm going to start by calculating number of moles. 12.82 over 287 gets me 0.0446-ish moles. Remember, don't round until your final step. It's fine to do the dots like I've done, but don't round till the end. Okay, so that's how many moles of the zinc sulfate substance that I have. Now, when that substance breaks down, it's going to produce the zinc sulfate and the 7 waters. So for every 1 mole of the reactant I've got, I will make 7 moles of water. So I'm going to work out how many moles of water I've got by timesing my moles by 7. Okay, I'm just going to put that straight into the calculator, so it will be a nice round number. That gets me 0.312 moles. I know that the MR of water is 18, so mass is equal to number of moles times the MR. Mass is equal to 0.312 multiplied by 18, which gives me 5.62 grams. And it has also told me in the question that 1 centimetre cubed of pure water has a mass of 1 gram. So if the water I've got weighs 5.62 grams, that means I've got 5.62 centimetres cubed of water. Different experiment. Maximum amount of water that could be produced is 8.5 centimetres cubed, and the percentage yield is 20.3, sorry. Okay, so the way that we calculate percentage yield is we take the actual amount and we divide it by the possible and we times by 100. It's given me the percentage yield, that's 20.3. Okay, we want the actual, and it's told us that the possible is 8.5, so you just need to rearrange that equation and you will get 1.73. Okay, an improvement in the apparatus that would increase the percentage yield of pure water. If I go back up to look at my diagram. Okay, so this is a pretty poor method of collection because as you're heating it, the hydrated part, the water that you've produced, is going to come out. It'll go down this tube and it's going to come out into the measuring cylinder. Some of it will, a lot of it will still be a gas at this point, and it's just going to float up and out of the tube. So you could improve it quite simply by putting your measuring cylinder into an ice bath. That would cool it down. But a better way would be to use a Liebig condenser or a condensing tube. Okay, so we are going to use a Liebig condenser this will cool and condense the water vapour, meaning less is lost. Okay, and that's the end of the paper, 110 marks. Okay, so we're going to start marking this paper now. So, question number 1, we've got the left and the right hand side of the screens. Okay, so chromatography, fractional distillation and simple distillation, 3 marks there. Okay, so we've got the bonded together mark, and then it says 2 different elements, but over here in the notes it does say allow 2 different atoms. I've said 2 different types of atoms, that's the same thing, so that's 2 marks. And then going down the page, 4 and 20. Okay, so total 7 marks for that question, no problems there. Question number 2, substances that are needed for iron to rust, oxygen and water. They've accepted air and water. And then the chemical name for rust, hydrated iron 3 oxide. So it did want the 3 there, so that was good that we went through and we worked that out. It is oxidation, which is C, that's fine. The procedure is called galvanizing, and then zinc is more reactive than iron, so the zinc reacts instead of iron. It will react before the iron, that's fine, so 2 marks there. Okay, any 2 from painting, coating it with plastic, oiling or greasing. You can plate it with chromium, which is a less reactive metal, and it acts, so if this is our rusty our iron object, it like totally coats it and means that the water and the oxygen can't get in through that barrier to get to the zinc. You can do sacrificial protection and also cathodic protection. We haven't done cathodic protection, you don't need to know what that is, but it is a valid choice, so they are allowing it as an answer. Okay, we've then got our state changes, which are fine, melting, sublimation and freezing. Okay, and we've got diffusion. Ammonia travels further in the same time, both okay. Okay, so there's a few different options for part 3. You can talk about the fact that the gas particles don't move in a straight line, they move in random directions, so it takes them some time to work their way through. You can talk about them colliding with the air particles, which is what I've done. And you can talk about them colliding with the wall of the tube. And then, as we discussed, goggles valid, gloves valid, lab coat valid. Okay. Next question. Okay, increase the rate of reaction, fine. Also mentions in the side bit there about copper not reacting with oxygen at room temperature. Argon does not readily lose, gain or share electrons, except it has a full outer shell, so no problems. And copper oxide at the side. Technically should be copper 2 oxide, because when you look at the formula it's CuO, and so it will be copper 2. However, it does say in the sidebar except copper oxide, so we would still get the marks there. Okay, the volume of gas remains constant, yet the results are the same. That's basically saying the same thing. And then we got a mark for working out the volume of oxygen. We got a mark for working out our total volume, and we got a mark for our final percentage, so that's 3 marks in total. A leak in the apparatus is fine. They've also mentioned the idea if you don't keep the temperature consistent, then the volume of gas will also change. So if there is any changes in the temperature, that would also have an effect. We've got our box. 1, 1 plus 1, 0, no problems. Look, this is something I highlighted in the video. The first word is critical. Okay, atoms of an element with the same number of protons but a different number of neutrons. All good. Protons and electrons gets you a mark, both being 12, and neutrons gets you a mark as 14. We've done our working correctly. Okay, so 1 mark for multiplying each mass number by the percentage. Second mark for adding them together and dividing by 100. Fine. Okay, good. That's 2 marks. No problems. Again, show your working. The working is worth a mark. So here it doesn't actually say. It does, sorry, yeah. So the right answer down here, right at the bottom right, the answer to 4 significant figures source 2 with or without working. So you get the marks just for the answer. Okay, oh, we've missed one. Right at the bottom there. Yes, no problem. Okay, sodium atom loses, oxygen atom gains, and then the third mark is for stating the number. Sodium loses 1, oxygen gains 2, so 3 marks. So I didn't actually need that bit, but sometimes it's worth writing it. I wasn't short on time. I did it all in 1 hour and 15 minutes, so actually I'm just making sure that I get the marks there by writing as much detail as I can. Okay, 62 mark gets you the mark. Okay, has ions or an ionic structure? Yes. Okay, and the ions in a solid are not free to move. They also don't have any delocalized electrons, which is the other thing that could cause something to conduct. So that is also a possible marking point, but you only need 2 out of 3. Flame test, yellow flame, fine for 2 marks. And then we have balanced correctly, and we've written the equation. Oh, only 1 mark, sorry, there. For doing that, because they gave you what the reactants were going to be. Okay, C, correct. You can see that as we go through, the amount of work they expect you to do for a mark increases. This was only 1 mark, but it was a reasonable amount of work. Okay, we get a white precipitate. And now we're on to our 5 marker. Let's see if we've got all of the points. Okay, filtering, good. Heating, good. And to evaporate some of the water, or until crystals first start to form, that's the same as the crystallization point. We leave it to cool. You can either pour off the extra liquid or we can filter. Yeah, and then a suitable method of drying. Place in a warm oven. Okay, they are allowing an oven, but they are allowing an oven. I don't agree with that because of the decomposition issue, but there we go. Dry in a warm place. Fine. Okay, so I've got 6 points there, which gives me my 5 marks in total, because that was the maximum. And what is the advantage? To make sure they're fully reacted. So all the reacted. Okay, so neither reagent is in excess. Same thing. Okay, go down. Good. A, C, propene. Same molecular formula, different structural formula. All fine. We've got our equation, which is good. Substitution, which is good. Okay, so 1 mark for your calculation, 1 mark for your answers, 1 mark for dividing through by the smallest number. So 3 marks there. Okay, our answer gets us 2 marks. If you didn't get that, then you get a mark just for doing the 127 divided by the 63.5 and getting an answer of 2. But you don't have to show your working for that one. That's all fine. 1 mark for the 2 carbon atoms, both with 2 hydrogens. So that's that one and that one. Get you a mark if you've got something like that. And then mark 2 is for the other 2 that I haven't circled. Okay, and then as I mentioned, the landfill sites are getting full. That could be a mark if you've talked about the burning, then it produces toxic gases when it is burned. Okay, the cotton wool prevents any acid from splashing out. Okay, so I've missed a mark there. That was the explanation mark. So pay attention to the number of marks in the question. Okay, so stops any acid from splashing out so that the decrease in mass is only due to the CO2. Alright, so pay attention to the number of marks things are worth. Clearly I wasn't doing that appropriately there because otherwise I would have spotted that. Okay, 2 marks, 1 for solid, 1 for 1 for solid and aqueous, 1 for liquid and gas. So that's all fine. Yeah, it stops because all of the HCl has reacted. And we know that it stopped when the mass remains constant or stays the same. Okay, mark 1 for correctly calculating the 0.98 from your graph. Mark 2 for the number of moles. No problems there. Okay, 1 mark for the tangent being shown on the graph, which I did. 1 mark for calculating the gradient, change in y divided by change in x. And 1 mark for the rate of reaction. Okay, it does say an answer of 0.005 to 0.06 is what they're expecting. But I've drawn a tangent. We can clearly see that it is a tangent there-ish. Probably should have been a bit more sloping like that to be a true tangent, and therefore they should accept that as a mark. Maybe not in this case because I was having some trouble with the ruler. It wasn't quite a tangent, it was a little bit off, so I'm going to give myself 2 out of 3 there. I still get 2 out of 3 for my working. Okay, we get a mark for saying that the rate increases as the concentration increases, and we get a mark for saying it's directly proportional. It says in the mark scheme mark 2 subsumes M1. That means if you've written directly proportional, you get both marks automatically because you've described the mathematical relationship, and that includes the fact that the percentage concentration increases as the rate causes an increase in the rate. So you get both marks if you said directly proportional. Increased concentration means there are more particles of acid. Yes, it changes the particles of acid and therefore changes the number of collisions per unit time. All fine. Okay, nitrogen, no problems there. Describe the forces of attraction in a covalent bond. We've mentioned our shared pair of electrons, and we mentioned the fact that they are attracted to two nuclei, so that's 2 marks. Substructure A is diamond, and then we've got our 4 marker on structure and bonding. A mark for saying that graphite is giant covalent, done. And a mark for saying that we are breaking covalent bonds. We haven't really explained that, so I'm not going to give that mark. I have said it can... Oh no, I have said that, sorry. It contains many strong covalent bonds, and these require energy to break. More energy to break. So I have mentioned the fact that we're breaking them. C60 is simple molecular, yes. And it is the intermolecular forces that are being broken. And more energy is needed to break the covalent bonds than the intermolecular forces. I've said that. So I've said all 5 things. It's 4 marks, so 4. Final question. Okay, we've got our chemical test for water. Anhydrous copper sulfate goes from white to blue. And then our physical test for water. Boil it, and if the boiling point is 100 degrees Celsius, then it is water. Okay, I haven't actually technically said measure the boiling point, but it does say allow, boil it or freeze it over on the side. So I'm going to allow it, but it probably would have been better in there to say that you have to actually measure it and then compare the boiling point. Okay, I get 1 mark for 12.82. Okay. They will accept your working if it's like up here next to a question, but be careful about doing what I did over here. If you go over the line there, you won't mark it because it can get cut off by the scanner. So there, I might potentially, if something useful had been written there, I might have lost a mark. It's not useful, so that's all right. Okay, mark 2, mark 3. Okay, I've lost something in my rounding here, so this is why you've got to be really careful with your rounding. So that would have been 3.13, which would have given me 5.63. Okay, so I would still get the mark because I'm timesing by 7, but I probably would have lost 1 mark there for not having my answer entirely correct. Actually, I wouldn't, because it says correct answer of 5.6 to 1 dp, which it would have been if I had left it as that, so actually 5. Okay, and then when we look at the final bits, 1.7, allow 2 or more significant figures, so no problems there. And then replace the delivery tube with a Liebig condenser, yes, and less water will be lost, 2 marks. Okay, so in total, I reckon I probably lost 2 marks across that paper, which would give me 108 out of 110. But remember, I did do that 2-hour paper in 1 hour and 15 minutes. So if you can be that quick, make sure that you go back and you check your working, because maybe I would have spotted those 2 marks if I had gone back and I'd checked my answers. Okay, have a look at how you did. Make sure you're comparing it to the ragging spreadsheet that I sent you. So if you've got things wrong, this will help you to identify what areas you need to go through to improve.